Welcome to another episode of TASC Mathematics. Today's mini lesson will focus on the power rule. Now, the power rule for the laws of exponents states that if you have a base raised to an exponent and that is raised to another exponent, you keep your base and you multiply your exponents. So let's look at our first example. We have 2 to the third, and then all of that is raised to the second power. Now the rule states you keep your base and you multiply your exponents. So I'm going to multiply 3 times 2, and my answer is 2 to the 6th power. Now the logic behind the multiplication of the exponents is if we take a look at what 2 to the third raised to the second power actually means. Now 2 to the third to the second power means that 2 to the third is going to multiply itself 2 times. And remember from the product rule, when the bases match, you keep your base and you add your exponents, which is 3 plus 3. And you get 2 to the 6. Now 3 plus 3, another way to write that is 2 times 3, because it takes 2 of these 3's to give you 6. So whenever you have a base raised to an exponent and then raised to another exponent, you keep your base and you multiply. Suppose we have x to the 9th raised to the 4th power. The rule states you keep your base and you multiply your exponents. So your answer would be x 9 times 4 to the 36th power. Now sometimes you can have more than one term within your parentheses. So here notice I've included a coefficient. I have 5 y to the 6, and all of that is raised to the second power. Now this exponent of 2 must be distributed to every term within the parentheses, which means that the 5 is raised to the second power and the y to the 6 is also raised to the second power. Now the 5, which is your coefficient, raised to the second power means 5 times 5. 5 times 5 is 25. Now for your exponent, you must remember when you have a base raised to an exponent and then raised to another exponent, you multiply those exponents. So you're going to multiply 6 times 2. So your answer is 25 y to the 12th power. Let's try a similar example. I have 3x to the 4th, and all of that is raised to the 3rd power. Remember, this 3 must be distributed to every term. So the 3 is raised to the 3rd power. X to the 4th is also raised to the 3rd power. Remember, 3 to the 3rd means 3 times 3 times 3, which gives you a value of 27. Remember, when you have a base raised to an exponent, raised to another exponent, you keep your base and you multiply 4 times 3, your exponents. So your answer is 27x to the 12th power. And that's your answer. Now these 4 examples were a little bit simple or easy. Let's take a look at a medium type problem. Now here I have 2 problems. Now this first one, I have negative 2a to the 7th, b to the 5th, and all of that is raised to the 4th power. Now inside the parentheses, I have 1, 2, 3 terms. What does that mean? Every term inside the parentheses must receive this exponent of 4. So negative 2 will be raised to the 4th power. A to the 7th will be raised to the 4th power. And b to the 5th will be raised to the 4th power. Now remember from our order of operations, right here, the negative 2 raised to the 4th power, because this 4 is even, my answer will be positive, and 2 to the 4th power will give you 16. Remember, when you have a base raised to an exponent and raised to another exponent, you multiply your exponents. So A, the 7 will multiply the 4, and for the B, the 5 is going to be multiplied by 4. So my answer is 16, A to the 28, B to the 20. And there is your final answer. Here I have 3xy to the 8 z squared, and all of that is raised to the 3rd power. Now every term within the parentheses will be raised to the 3rd power. So the 3 is raised to the 3rd power, the x is also raised to the 3rd power, the y to the 8 is raised to the 3rd power, and the z squared is raised to the 3rd power. Now 3 to the 3rd power will give me 27. Now remember, when you have a variable all by itself, there's an exponent, there's an invisible 1. So this x would be 1 times 3, the y 8 times 3, and our z 2 times 3. So our answer, 27, x to the 3rd, y to the 24, and z to the 6th power. And that's your answer. So remember, the power rule states when you have a base raised to an exponent and then raised to another exponent, you keep your base and you multiply those exponents. And remember, for those coefficients, you're going to treat those as normal numbers. Let's take a look at another example. Now suppose you're given a fraction. We can also apply the power rule to that. So here I have x to the 5th over y squared, and all of that is raised to the 9th power. Such as the previous examples, everything inside of the parentheses must receive the 9th power. So x to the 5th is going to be raised to the 9th power, and the denominator of y to the 2nd will also be raised to the 9th power. And remember, the rule states you keep your base and you're going to multiply your exponents. So your numerator is going to be x to the 45, while your denominator will be y 2 times 9, so it'll be y to the 18th power. The only difficulty is placing more variables within the parentheses. So here I have x to the 6th, y to the 3rd over z to the 5th, and all of that is raised to the 5th power. Therefore, every term inside the parentheses will be raised to the 5th power. The x to the 6th to the 5th power, the y to the 3rd to the 5th power, and the z to the 5th to the 5th power. And remember, the rule says when you have a base raised to an exponent and raised to another exponent, you're going to multiply those exponents. So your x, you're going to have 6 times 5, the y, 3 times 5, and your z, 5 times 5. So your answer, x to the 30th, y to the 15th power over z to the 25th power. Let's look at some more examples. Now, when it comes to the laws of exponents, they like to combine more than one rule. So here I have my power rule and also my negative rule. Remember, I said I'm going to sprinkle in the negative rule as we go along. So we're going to look at the negative rule again. And remember, the negative rule is if you have a base raised to a negative exponent, to make it positive, you write the reciprocal, which is 1 over a to the positive m. So here I have my power rule again. I have x raised to the negative 2 and all of that raised to the 7th power. And the rule states you keep your base and you multiply your exponents. So I'm going to take negative 2 and times it by 7, and I get x to the negative 14. But we don't want negative exponents, so we have to write that in the positive form. So that would be 1 over x, and now my exponent become a positive 14. Let's try that again. Over here, I have 3x to the negative 5, y squared, and all of that is raised to the third power. So the 3 is raised to the third power. X to the negative 5 is raised to the third power. And the y squared is raised to the third power. Now 3 to the third power is 27. X, when we multiply my 5 times my 3, I'm going to get negative 15. And the y, when I multiply 2 times 3, I get 6. But remember, negative exponents are not allowed. So I'm going to have to write the x to the negative 15 in the positive form. So today when I taught my class, I told them, okay, we're going to make this a fraction. And to make anything a fraction, you just have to put it over 1. And we call it the upstairs downstairs rule. If you have a negative exponent, to make it positive, it has to switch positions in order to become positive. So here, the 27 is okay, that can stay. The y to the 6 is already a positive exponent, so it doesn't need to move. However, the x to the negative 15, that is a negative exponent. So to make it positive, it's going to come to the denominator position and become a positive 15. So remember, you only move negative exponents. Only negative exponents. Negative integers are allowed. Coefficients, if they're negative, are fine. They don't need to be moved. Let's take a look at another example. I have 2a to the negative 7, b to the negative 3, and all of that is raised to the 5th power. So everything in the parentheses must be raised to the 5th power. The 2 is raised to the 5th power. The a to the negative 7 is raised to the 5th power. And the b to the negative 3 is raised to the 5th power. Now 2 to the 5th power means that 2 is going to multiply itself 5 times. That gives me a value of 32. Now remember, you're going to keep your base of a, but we're going to multiply negative 7 times 5, and I get negative 35. And the b, I'm going to multiply negative 3 times 5, and I get negative 15. Now technically this answer is correct, but if you're on the test and they says only positive exponents, we're going to have to rewrite this. So as always, I tell my students, make a fraction. So we'll put this over 1. The 32 is fine. That will stay in the numerator. Now here, the 35 is negative. So to make it positive, we're going to take it downstairs. So it becomes positive 35. B to the negative 15, negative exponents are not allowed. So to make it positive, it can't stay in the numerator. It must be moved to the denominator position. And it becomes positive. So your answer is 32 over a to the 35 and b to the 15th power. Now let's make it really interesting. Let's combine 3 rules. Let's combine the power rule with the product rule and also the negative rule. So here I have x to the 4th and I'm multiplying by x to the 2nd raised to the 7th. I have 2 rules going on here. I have the power rule here with the x squared raised to the 7th, but then the whole problem is the product rule as well. Oh, my pen doesn't want to write. So what will we do first? Well, remember order of operations? So we have product and power. And power is like your exponent. So we're going to do the power rule first. So I'm going to key x to the 4th. And remember the power rule says, you're going to keep your base and you're going to multiply your exponent. So I'm going to multiply 2 times 7. So this is actually x to the 4th power times x to the 2 times 7 is 14. So I did my power rule first, and now I'm going to do my product rule. And the product rule states, if your bases match and you're multiplying, you keep your base and you add your exponents. So I'm going to add 4 plus 14. So my answer is x to the 18th power. So in this example, I had the product rule and also the power rule in play. We evaluated the power rule first to get x to the 14th, and then we applied the product rule, which says keep your base and add your exponents. Let's take a look at another example. Now I have 2a to the 4th, b to the 5th, raised to the 3rd power, and I'm multiplying 3ab to the 9th, raised to the 2nd exponent. Now here I have power here and power here, but then all together this is product. So what should you do first? Yes, you guessed it right. We have to evaluate the power first. So we have 2, which is raised to the 3rd power, a to the 4 to the 3rd power, and b to the 5th to the 3rd power. Over here, the 3 is raised to the 2nd power, the a to the 2nd, and the b to the 9th to the 2nd power. Now 2 to the 3rd power, that would give me 8. Now remember, when you have a base raised to an exponent and raised to another exponent, we multiply, so that's a to the 12th. And the b, 5 times 3 is 15. Over here, 3 raised to the 2nd power is 9. Now remember, if you have a variable all by itself, there's an invisible 1 there. 1 times 2 is 2, so that's a to the 2nd power. And then the b, 9 times 2 is 18. So we finish with the power for our two products. And now we're going to do our last step, where we're going to multiply. So 8 and 9 will multiply each other. A to the 12th is going to multiply a to the 2nd, and b to the 15 is going to multiply b to the 18. So remember these coefficients, you're going to treat them like normal integers. 8 times 9 is 72. Remember the product rule? When your bases match, you keep your base and you add your exponents. So that's 14. For the b's, we're multiplying, so we're going to keep our base and we're going to add our exponents, which is 15 plus 18. So that will give us, I think, 43. Am I correct? You have 8 and 5 is 13. 1, 2, 3. Sorry, 33. I'm a little bit off. 33. Now let's look at our last example. So here in this example, I have the power rule, the power rule, product rule, and then I see some negatives. So we're going to do power rule first. So that's x to the negative 5 raised to the 2nd power, y to the negative 3 raised to the 2nd power, x squared raised to the 3rd power, and y4 raised to the 3rd power. And remember the power rule, you keep your base and you multiply. Negative 5 times 2 is negative 10. For our y, negative 3 times 2 is negative 6. For our x's over here, 2 times 3 is 6. And for my y, 4 times 3 is 12. So we did the power rule first. Now we're going to do the product rule. And the product rule states that when your bases match, you keep your base and add the exponents. So the x to the negative 10 is going to multiply the x to the 6. the y to the negative 6 is going to multiply the y to the 12th. Now here I'm going to keep my base of x, and I'm going to add negative 10 plus 6. I'm going to keep my base of y, and I'm going to add negative 6 plus 12. Remember your rules for adding integers. When the signs are different, we perform a subtraction, which would give us 4, but we keep the sign at a larger absolute value. And then for our y here, the signs are different, so we subtract, gives us 6, but we keep the sign at a larger absolute value, so it's a positive 6. But remember, negatives are not allowed. So make your fraction, put it over 1. Now, since this has a negative exponent, it cannot stay in the numerator. It's going to go to the denominator position and become positive. The y to the 6th power is okay because that 6 is positive, so it can stay in the numerator. So your final answer, after all that hard work, is y to the 6th over x to the 4th. I hope these examples have been helpful for you as we looked at the power rule, and we then blended the power rule with the negative rule. Then we blended the power rule with the product rule. And then we blended all three: power, product, and negative. Wasn't that fascinating? I hope you've enjoyed this video, and have a good evening.